syntax directed translation. That is, so far we have discussed how the different parsing techniques works. That is, how we can construct a parse tree. The parser, that is the syntax analyzer, will take the input from the lexical analysis phase and it will construct a parse tree. Now it is the role of semantic analysis phase. So the input to the semantic analysis phase is the parse tree generated by the syntax analyzer. That is, the parser will construct a parse tree and give this parse tree to the semantic analysis phase. So it is the responsibility of the semantic analyzer to evaluate the meaning of the parse tree, whether the parse tree is meaningfully correct or not. So the semantic analyzer will verify the parse tree. It will verify the meaning of the parse tree. So we need a set of semantic rules in semantic analysis phase. So the input to the semantic analyzer is a parse tree, as you know, and the semantic analyzer will take grammar along with the syntax rule to evaluate the parse tree constructed by the parser. So here is this grammar plus semantic rules is known as syntax directed translation. Okay, that means the semantic analyzer will verify the parse tree, the meaning of the parse tree, by using a set of semantic rules. So the semantic analyzer will take the output of the syntax analyzer, that is the parse tree, and it will verify this parse tree using the grammar along with the semantic rules. And this set of grammar plus semantic rule is known as syntax directed translation. So syntax directed translation, the semantic rule, there are two classification of the semantic rule, two methods. So one is called the syntax directed definition and syntax directed translation scheme. Syntax directed translation scheme. Syntax directed definition and syntax directed translation scheme. So what is this syntax directed definition? As we have said earlier, the semantic rule for each production in the grammar. Consider this example. This is our grammar and this is our semantic rules. Semantic rules. Okay. So for each production in the grammar, we will have corresponding semantic rules. Okay. For example, E gives E plus T. E gives E plus T. That is our production rule. And the corresponding semantic rule is E dot val equal to E dot val plus T dot val. That means in syntax directed definition, we will define a rule for corresponding production. Define a semantic rule for corresponding grammar production. Okay. And here for every symbols used in the grammar is associated with some attributes. In this example, E dot val, this val is the attribute for the non-terminal E. So this attribute there can be 0. In some cases there will not be any attribute for the symbol. In some cases there can be one or more attributes. So E dot val, this val is considered as an attribute. Okay. So these are called, this val is the attribute. For every symbol in the grammar, we will have 0, 1 or more attributes. Okay. So syntax directed definition deals with the definition of the semantic rules. For every production in the grammar, there will be particular semantic rule. That is, each production is associated with a semantic rule. Okay. That is called the SDD. This is the definition of the semantic rule. How this is defined. What are the attributes? How the attribute values are calculated and how it is defined. The method of representation. These are all defined by syntax directed definition. Then SDT, that is syntax directed translation scheme, means how we can traverse the parse tree to acquire value for these attributes. That is called syntax directed translation scheme. Okay, before that, in this SDD, we said that each symbol in the grammar is associated with some attributes. There are two types of attributes. One is called one is called, this SDD is also known as attribute grammar. SDD is also known as attribute grammar. Okay, this is also known as attribute grammar. So we have two types of attributes. One is called synthesized attribute and inherited attribute. Synthesized attribute and inherited attribute. Okay, a synthesized attribute, for example, suppose consider the production A gives B, C, D. Okay, and the tree will be like this. A gives B, C, D. That is, A can be expanded like this. So suppose A dot value equal to B dot value. A dot value equal to B dot value. Suppose this is the semantic rule associated with this production. For A dot value equal to B dot value. That means A is getting its value from its child node. Okay, A is getting value from its child B. Such type of attribute, if an attribute is acquiring value from its children nodes, then that type of attributes are called synthesized attribute. So a symbol, a non-terminal, if it is taking value of its child, it is known as synthesized attribute. Okay. Then inherited attribute means, same example, suppose if the semantic rule is like this. For example, C dot value equal to A dot value. What is happening here? C is taking value from its parent. Okay. C dot value equal to A dot value. This node C is taking value from its parent. Such type of attribute is called inherited attribute. Similarly, like this, D dot value equal to B dot val plus C dot val. This is also, okay, inherited attribute. That is, if an attribute, for example, D dot value, D is taking value from its siblings. Okay, so if a non-terminal, if a symbol, the attribute of a symbol is taking value from its parent node or from its siblings, then it is called inherited attribute. Inherited attribute. So SDD is also known as attribute grammar, and in SDD it can be classified into, there are two types of attributes: synthesized attribute and inherited attribute. Synthesized attribute means attribute which is taking value from its child nodes, then that is called synthesized attribute. If an attribute value, if the attribute of a symbol is taking value from its parent node or from its sibling, then that type of attributes are known as, it is known as inherited attribute. Okay. Okay, so there are two types of attributes, synthesized and inherited attribute. So this comes under SDD, that is syntax directed definition. So when you consider the grammar, for example, in this particular grammar, each production rule is associated with a certain set of semantic rules. So this semantic rule, the definition of the semantic rule is known as syntax directed definition. Then how the values are calculated by traversing the tree is known as syntax directed translation scheme. Syntax directed translation scheme. Okay, so let me draw the parse tree for this grammar, that is id equal to id plus id into id. Okay, I am changing it as id. So the tree will be like this: E gives E plus P. Then this E can be T, T can be, sorry, one more. this T can be F and F can be ID. Okay, this is T. Then this T can be again T into E. This T can be F. T can be T into F. T can be F and F can be ID. Similarly, E can be T, then T can be F, then F can be ID. Okay. So this is ID plus ID into ID. Okay, this is our string. And the parse corresponding to the string is this one according to this grammar. So how will we, that is in syntax directed translation scheme, we will apply this semantic rule to verify this parse tree. Okay, so the traversal will be always sent from top to bottom, left to right. Okay, we will traverse the tree from top to bottom, left to right. Whenever you see a reduction, you take the production and apply the particular action specified in the semantic rule. Okay, that is, we will start from the start symbol. We will start from the top of the tree and we will traverse the tree from top to bottom, left to right. Whenever you see a reduction, whenever you see a reduction, take the corresponding production and apply the corresponding semantic rule. Okay, so here is a reduction, that is this ID can be reduced to F. ID can be reduced to F. So what is the production? F gives ID is the production. And suppose we are giving value like this, 2 plus 3 into 4. This is our value. Suppose I am giving value like this. So value of this ID is 2, this ID is 3 and this ID is 4. Suppose these are the values. So whenever we identify a reduction, so this is a reduction, ID is reduced to F. So we will take the corresponding production, that is F gives ID, that is the production rule. And what is the semantic action here? F dot value equal to ID dot lexical value. And what is the lexical value here? That is 2. I have given 2. So F dot value becomes what? That is ID dot lexical value. And what is the lexical value? That is 2. Okay, again we will traverse upwards. This is again a reduction, that is F is reduced to T. F is reduced to T. So what is the production? T gives F. And what is the action given in the semantic rule? That is T dot val equal to F dot val. What is F dot val? It is 2. So T dot val becomes F dot val, that is equal to 2. Again, then this T is reduced to E. That is, the rule is E gives T. E gives T, and what is the action? E dot value equal to T dot value. So E dot val equal to 2. Then again we will traverse like this. This is not a reduction, and next reduction comes here. This ID is reduced to F. ID is reduced to F. So what is the action? F dot value equal to ID dot lexical value, and the lexical value here, the value I have given is 3. So F dot val equal to 3. Then again this F is reduced to T. So T dot value equal to F dot value. This is the production and corresponding action. So T dot value equal to F dot value. What is F dot value? It is 3. Then again it goes up. It will traverse like this. Okay. Now this is a reduction. This ID is reduced to F. So what is the value? F dot value equal to ID dot lexical value. And what is the lexical value here? It is 4. Then this is also a reduction. F is reduced to T. F is reduced to T. That is T gives F. So T dot value equal to F dot value. T dot value equal to F dot value, and F dot value is 4. F dot value is 4. Then again this T is reduced to E. T is reduced to E. E gives T. E dot value equal to T dot value. So E dot val equal to again 4. Now this is a reduction. T gives, that is T is reduced to T into E. T gives T into E. That is this is the production. Okay. Oh, sorry. This is. Oh, sorry. This is not E. This is F. Okay, 1 minute. This is our F. T equal to T into F. F can be written as ID. Okay, so this is the reduction. F gives ID. This is F dot val equal to, this value here is 4, equal to 4. Okay, so this is a reduction. T gives T into F. This thing. T gives T into F. So T into F. This is a reduction. So what is the rule associated with that? T dot value equal to T dot val into E dot val. So T dot val equal to T dot val, that is equal to 3 into F dot val, that is 4. So what it becomes? 12. Okay. Now again, this is a reduction. E gives E plus T. This is a reduction. E gives E plus T. And what is the value of E? E dot val equal to E dot val plus T dot val. That is 2 plus 12. 2 plus 12, that is equal to 14. This is how a tree is traversed. Whenever we traverse a tree, we will start from top to bottom, left to right, we will traverse. And whenever you identify a reduction, take the corresponding production and apply the corresponding semantic action. This is how we can traverse a tree. Okay, this is known as syntax directed translation scheme. So, okay. And if you get the correct value, then we can say that this tree is semantically verified. Okay, thank you.